Find the numerical value for the term independent of x in the expansion 2x plus 1 over x squared. Okay, the first thing we notice is there is no degree given to us. That was the problem with this question back in the 1980s. I don't know. So we cannot really do this question, but I'll just drop this here. We would have to use the binomial expansion formula, which is n combination ra to the power n minus r b to the power r. Now what is a? A is going to be the first term, and then b is the second term. So if we had the degree, which is the n that we need, we'll be able to work this question out. And I really love binomials. So let's just move on. Question number 4. Find the set of values of x for which 2x squared plus 3x plus 2 is less than 4. Okay, that's a quadratic equation. That's why it even says set of values. So we're just going to work this out as normal. We'll start by, let me write this down first. Start by subtracting 4 on both sides to isolate this. So we have 2x squared plus 3x plus 2 minus 4 is negative 2 less than 0. Okay, now you can either use a quadratic formula here or you use the factor method. So I'm just going to use the factor method. I am going to have to multiply the 2 by this 2 since the coefficient of x squared is not 1. After I multiply these two together, I will get a 4. So practically I'm doing 2x squared plus 3x minus 4. Or let me just put this at the top so we don't forget. Okay, that's better. So I'm finding two numbers that when I multiply, it gives me 4. But when I add, it gives me 3, which is pretty simple. I would take -1 and +4. So the two numbers we're searching for are -1, +4. Keep in mind this sign also applies to the 4, so let me just mention that over there. So this is supposed to be -4 right here, and then -1 plus 4, definitely a 3. So we just erase that. Okay, and we move on. So I'm going to use my factors. 2x squared, the numbers we had were +4, so 4x, and -1, so -1x minus 2 less than 0. Then I'm just going to factorize 2x here. X plus 2 would be left over. I can factorize -1 here so that x plus 2 is still left over. Keep in mind we have to make sure these internal ones are the same. Okay, and then 2x, hold on, we factor out the x plus 2 and then we do 2x minus 1 less than 0, just like that, and then we take each of them being equal to 0, because if two numbers multiply to give you a 0, then either of them has to be a 0, right? Okay, next we have x would be less than -2, or we have x less than +1, divide both sides by 2. So in this case we can rewrite the equation. We always have to start with a smaller one, so -2 has to go first. This would be -2 less than, if x is less than -2, that means -2 is greater than x, and then we have x less than 1/2. Okay, perfect. So we have x in the middle, We combine it to get our interval, so -2 less than, why do I keep saying less than, greater than x, but less than a half. And now for the set of values, well, this already represents the set of values. You can write them out if you want to, but then there's going to be a lot of them. So question number 5.